Let's look at polynomials today. And again, we're combining these lessons, so it's going to go by a little bit quickly, but polynomials aren't actually that difficult in the beginning because you're just learning the vocabulary for it right now. So let's see. Polynomials. Well, what is a polynomial? First of all, it's an expression that has more than one part, basically. And so if we had 2x, that's actually a polynomial. We just have a special name for it because it's only one. We call this a monomial. Okay, the key thing about polynomials is that they have parts that are called terms. Okay, each part is called a term. So this is a term, 2x, but if it's just by itself, we call it a monomial. If it was 2x plus 1, that would be a binomial because it has two parts now. Bi stands for 2, mono stands for 1. Three would be a trinomial, and if you got more than that, you just use the term polynomial usually. But polynomial can cover all of these because poly means many, and as long as you have different terms, we're going to call it polynomials basically. All right, so each one of these is a term. Okay, this is a term, this is a term, this is a term. Each piece is a term, T-E-R-M. Let's say term. All right, well, a number by itself is just called a constant because it stays the same. It's just a number. So we have different terms, we have different constants. All together we make polynomials. The number in front of a variable, let me use a different color to do this one. The number that's being multiplied times a variable, this factoring, that is the coefficient. Remember that word, coefficient. So you have the whole thing is a term. You have this is the coefficient, that's the variable. And if you put it with other pieces, you have polynomials. Most of these words we've probably heard before, especially terms and coefficients. But now we're just adding on our new words, polynomials. All right, let's see. So let's tell whether these expressions are polynomials. Okay, to be a polynomial, you need to have a positive exponent, basically. You cannot have a fractional exponent, and you cannot have a negative exponent, because remember, a negative just flips it over. And you can't have an exponent to another exponent. That you can't have like 5 to the y. Okay, that's not a polynomial. No. 3x to the negative 2. No, not a polynomial. 3x to the 1/3. No, not a polynomial. Okay, so let's see if we can tell whether these are polynomials or not. 3x to the negative 2? No. 6x plus 4x squared? Yes. 15? Yes. Remember, it's a constant. It's fine. 2 plus x to the 1/2? No. So polynomials cannot have negative exponents, and they can't have fractional exponents. Can't have exponents to a variable. You can't have a variable on top. So let's look at some more. For the expressions, let's look and see if we can identify the terms. Okay, well, let's see. I'm going to use a different color now. Back to red. The terms, well, each piece is a term. The coefficients, well, the coefficients, I'm going to write C right here just for to save time. The coefficients would be 6 and 4. Those are the numbers in front of the variables. And the constant term, well, this one doesn't have a constant term, but over here on C, that would be 15. That would be the constant because it's just a number. So it's just sort of vocabulary, okay? All right, now there's another term that we're going to learn is called degree. That's going to be the highest set of exponents, okay? The highest exponents on the term. And if you have more than one variable, you add the exponents. And I'll show that in just a second. 4x to the 5th power. That's a degree of 5 because the highest one is 5. And what's the coefficient? 4. 12x cubed. The degree is 3. That's our highest exponent. And the coefficient is 12. X squared. The degree is 2. Okay, the coefficient, remember, is 1. And then negative x, that's a degree of 1. Because, you know, we have a degree of 1 right there, and the coefficient is negative 1. So let's look at this real quick. If I had 6x squared y squared, well, the coefficient would be 6. The degree would be, well, I have 2 on this one, and I have 2 on this one. It's 2 different variables. So the degree would be actually 4. Because when you have different variables, you need to combine your exponent values to find the degree. So right here, let's see. We have 2x squared plus 3x plus 7. The degree is going to be the highest one, which is 2. The constant is 7. That's just a number by itself. We have negative 5y cubed plus 4y cubed squared minus 8y minus 3. The degree is the highest one, which is 3. And the constant is negative 3. That's a number by itself. 36 plus 12x plus x squared. The degree is 2. And the constant is 36. Standard form is we usually just write the highest degree in the front, and we kind of go down in order from there, all the way to the constant at the back. We'll use the term leading term. That just means the one in front. Okay, remember each piece is a term. The numbers in front are the coefficients. You have the degrees. But the standard form to write these is just in descending order. All right, remember, I've already talked about monomials being 1, binomials 2, trinomials 3, and if we got more than that, we just call it polynomials. All of them are kind of polynomials. We just like to name things specifically sometimes to help make it easier. So let's see, real quick, let's see if we can do this chart. Here's the polynomials. Let's say the number of terms. There are 2 pieces. Those are the terms. If we have 2 pieces, we would call it a binomial. Binomial. The leading coefficient, that's the one in front, and we put them in order, that's going to be 3. 3 is the coefficient of the one in front, the highest degree. All right, the constant term, 0. It's not there, so we're just adding zeros. And then the degree is 2. That's the highest exponent. Is this statement true or false? All polynomials are binomials? False, because polynomials could be monomial. They're getting tongue-tied. Polynomials could be monomials, or it could be binomials, or it could be trinomials, or quadrinomials. Okay, polys includes all of them, but bi is a specific form. So not all polynomials are binomials, but if you flipped it, all binomials are polynomials. So just semantics, the way the words you're used. If I wanted to write the first step and putting this into standard form, I would move this negative 5x squared in front. And then I would have descending order. 3x would be next, and 7, our constant term, would be last. I would put that into standard form. The first way to do is to move this to the front. All right, name the coefficients of the terms. 4, 3, -9. Those are my coefficients. So I think that's pretty simple. Most of this is just learning the way to identify the different pieces. Let's look at adding polynomials. All right, again, like terms. You have to be able to add like terms, and that's basically all there is to it. X minus 2 plus 2x plus 5, well, x plus 2x is 3x. Minus 2 plus 5 is plus 3, 3x plus 3. All right, let's see, 2y squared plus 3y squared, that would be 5y squared. I don't have any other y terms, so it's just plus 3y. And then I have 6 minus 4, which is 2. So adding like terms is basically all of this is. Just make sure if you have a negative sign, you distribute it to every term inside. We might see one of those in just a second. All right, are these terms like or unlike? Unlike. One is a exponent of 3 and one doesn't have an exponent, so those are unlike terms. 5 and 5x, unlike. Negative 3y and 3y, like. We can combine those, it'd be 0. X squared y and xy squared, unlike. 14 and negative 0.06, that's like. Those are both constants, okay? Make sure you can tell the difference between like terms and unlike terms. All right. Sometimes you might want to add them vertically instead of horizontally. That's up to you. Let's just see. I'm trying to find one with a negative sign in here. I don't think they're going to do that on this lesson. It might be the next lesson. But it's basically just distributing the signs. Let's see real quick. 3x squared plus 2x squared is 5x squared. X plus x is 2x. 5 minus 5 is 0. So that would be the answer to this one. Remember, your coefficients are 5 and 2. The degree is 2. Okay, there are 2 terms, so that's a binomial. It's just combining all the different vocabulary we just had. All right, let's go down to subtracting. Same exact way, except just remember to distribute the negative sign. So if I have 5x minus 5 minus x plus 7, well, that's going to be 5x minus 5. All right, this minus sign distributes, so it's minus x and then minus 7. 5x minus x is 4x. Negative 5 minus 7 is negative 12, minus 12. 4x minus 12. Pretty simple. Just remember to distribute this negative sign to everything in the parentheses. 2 negatives make a positive. And then combine normally. Watch out if you're doing it vertically, because you do need to. He did not distribute the negative sign on this one. This should have been a minus x squared. That's right. It should have been a minus 2x. That's not right. And it should have been a minus 4. So just watch out if you're doing these things horizontally, because you have to distribute the negative sign just like you're doing it vertically. I'm sorry. Watch out if you're doing it vertically. You need to distribute the sign just like you do when you're doing it horizontally. And that's basically the basics of polynomials.